Yeah, thank you, Craig, and thanks everyone for joining the session today. Our discussion will be about network slicing. At DZS, we talk about things like intent-based slice management, but it's probably good for us to take a step back and just look in general what's happening in the industry here. So that's where I'll be taking us today. As Craig mentioned, I'm the Chief Technology Officer of DZS. We've had a lot of exciting changes and announcements at the company and about 20 years of history with a baseline in optical broadband. But we've been active recently in expanding to mobile and software, and this is slicing is a key topic in these domains. So as Craig mentioned, that's where I'd like to focus in our discussion today. So here's a list of the topics we'll be covering. We'll start with context and really an explanation background on network slicing, our perspective on what it means and why it exists and so forth. We'll talk a bit about the decision criteria for operators who are going to implement network slicing in the context of what's happening in the industry. We'll look at the status of the ecosystem. Again, as mentioned, this is a vibrant area, so there's a lot of activity here, including from a standards perspective, and we'll visit that briefly. Even though that mobile is where our discussion will start today, the fixed network actually has a significant bearing on what we do from a slicing perspective. So we'll talk about that and the activities of the BDF in this area too. A related topic is an important one, also a BBF work stream, and that is wireless and wireline convergence and how these networks come together. And then we'll close with some thoughts and commentary from my side. So much of our focus, as I mentioned in the broadband forum, is fixed and broadband technologies. But to start the discussion on slicing, since the genesis of the slicing concept comes from the mobile domain, is generally attributed to one of the industry trade associations called the Next Gen Mobile Networks, or NGMN. We'll start by calibrating with a simplified view of 5G. This picture we may have shown and talked about before, but we'll use it to explain the context of slicing. So this one goes from right to left, I guess, if you think about the user or the access portion. So you might have smartphones, you might have fixed wireless access using the 5G, or maybe a combined 4G, 5G network for residential, for business, for education, various verticals. That in turn interfaces to a radio network. So this is where radio heads, tower sites that we're all familiar with, that we see on the road or in the cities, where these are the first point of connection between our user equipment, as we call it, and the mobile network in the radio access network. So in some cases, many cases today, these will be 4G sites, but increasingly, as you hear and as you're seeing, 5G technology is becoming prevalent and is a key focus of where our deployments are occurring now. And 5G in turn has given rise to a new kind of architecture shown in this picture, which is distributed, in many cases virtualized, and the various strategies about how that can be accomplished. But a key one is a so-called open radio access network that emphasizes software-defined components. So supporting that architecture is the notion of a packet-based network interconnecting elements all the way from this radio site that we talked about to what we call a front haul case. There might be something such as a front haul gateway that is aggregating this packet-based traffic that's now coming directly from the radio site, or maybe in 4G networks, a traditional serial kind of specific wireless interface. And in turn, passing this traffic on towards the core of the network. Now, the remaining part of that radio access network may be composed of a baseband unit, a digital unit, In the Open RAN world, we have some distributed software-based components we refer to as a centralized and distributed unit. And these are maybe out at the edge of the network in one of these edge data center, edge compute type of cases, or they may be centralized, depending on the circumstances and the strategy of the operator. But in many cases, these gray elements shown in the middle here, connected by mid-haul, are software-based elements today. So leveraging compute functions, leveraging virtualization, leveraging data center technology to implement network functions. As is the case in many traditional base station sites, going back to 2G and 3G, even is a cell site router. This is an element like a piece of transport equipment as well that prepares the traffic and connects a base station site or a part of the radio access network into the core. So various types of network elements there, some packet-based, some optical in nature, some combined. A lot of things happening there, which we could probably do another good talk on. But they all do participate in slicing, as it turns out, in the act of passing on this traffic to the mobile core and data networks such as the public internet. So that's really the full picture, but a very schematic, high-level view, just to introduce the notion of where slicing fits in. So as I mentioned, a key concept in how we're realizing 5G networks is software defined, or what we started to call virtualized network functions. You may hear these now referred to as containerized network functions, depending on the infrastructure strategy that is used to deploy and implement these functions. And so this is a reality of any virtualized network, including the wireline networks that we use for broadband. If you think about the BBF Cloud CO initiative, for example, very much aligns with this kind of philosophy, but in a different part of the network, which we'll talk about going forward here. So this new network, 5G networks, especially in the radio access network, leverage this notion of software defined and virtualized components as shown in the diagram here. But this network, as discussed, also has a variety of physical network functions as well that are necessary to interconnect the virtual functions. So the industry continues to look at, we continue to look at as vendors and standards and trade associations, what is the right balance of physical versus virtual hardware, specialized hardware for packet processing functions, for radio functions, versus those things that can be implemented in software, maybe exclusively in software, and therefore be very, very flexible, very agile, easy to deploy and distribute, versus scaled up and implemented in mass. And I predict that these areas will all continue to change as we identify new ways to leverage software control or software flexibility, either embedded in some of these physical network functions because they too run software, or in standalone capabilities as shown here. The reason I wanted to highlight both of these directions, both of these possibilities, is they are in an end-to-end approach of network slicing, meaning if network slices are to be created, both types of network elements must be addressed because they all need to be part of such a slice. So now that we've talked about the network, we've talked about the distinction between software-defined and physical network functions, we should talk about network slicing and what it is. So simplifying further this diagram that we have here, one of the criteria for network slicing according to standards is that you must support at least one slice typically. And what does it mean to have a slice? Well, this cascade of elements that we just talked about, from the UE at the right-hand side of the screen, user equipment, right-hand side of the picture here, all the way to the core and the internet on the left-hand side of the picture. In many cases, maybe with the exception of the UE, unless you have a lot of friends, these elements that are in the operator network are shared in some fashion. That means multiple users, multiple service types will be applied to this infrastructure. But not all users, not all service types, not all services, applications have the same parameters, the same class of service, the same requirements in fact. So this fundamentally, what we're showing here is a shared infrastructure being used for the wireless network, just as in many cases we do the same thing for broadband services and consumer broadband, enterprise, and so forth. So given that infrastructure is shared, the key question is, how do we provide those differentiated services in what is potentially, but not always, shared infrastructure? Meaning, how do we enable those separate categories of services, those separate parameters for each one of these services? One slice that you might define is with an associated set of these parameters is a slice or an instance that might be used for a conventional smartphone service if you're a mobile network operator. In fact, this might be one of the primary slices that you have, because most users or most services fall into this category of requirements. But more and more in the 5G realm, we're also hearing about enterprise users, specific vertical industry use cases that might not be human users. They might be industrial users, or they might be traditional user equipment with special requirements, or services with special requirements around security, around data sovereignty, around the quality of service that's being provided, and so forth. So the notion of identifying a new additional slice that can be assigned to this shared infrastructure shown in the diagram here is a way that these service classes could be differentiated in either shared or dedicated infrastructure. Extending this model further is an example of an IoT type slice. So this is maybe a special case of that vertical industry situation that I just mentioned a moment ago, where the network is now being used for machine to machine or embedded type of applications or connectivity, which in turn might have some special requirements for cost, for scale, for coverage, to provide, for example, cost-effective telemetry for managed devices at the edge of the service area and so forth. So once again, each one of these slices, potentially sharing some or all of the infrastructure shown in this picture, will have different parameters, different population of subscriptions, not necessarily users even, that in turn drive different functionality and different assignment of resources within the network. So how would one accomplish or implement slicing is a key question. Once you've implemented slicing in the shared network context, the real issue is how to control and deploy slices in an efficient way. The industry consensus we see is that there's a need for a slicing-aware service orchestration and domain orchestration capability to address both these physical and virtual elements in the network. And regardless of your viewpoint or your entry point to standards, most of the architectures that support the realization of slicing have some such model of an end-to-end capability that allows the provisioning, the creation, the definition of templates that in turn define the parameters of what a slice is and how to address the elements that participate in such a slice. So here's a figure from a GSMA white paper a few years ago introducing network slicing. GSMA is another trade association that did some work in describing network slicing. And this is a pretty good summary of the different parameters that one might use to define a slice, what network capabilities are required. And in this in this radial plot here, you have kind of the sense of, for any given slice, such as those 3 cases that we talked about before, you might optimize or increase or decrease the preference or the resources or the level of capabilities in each one of these areas to really optimize the overall performance of the network for those types of services or user classes. So I think this is a good example, once again, of what factors might define the key parameters of a slice, but they're not necessarily exhaustive. Some of these are treated in standards. Some categories not shown here are also treated in standards. So really the key concept is enabling framework to define these different parameters that in turn result in actions, configuration, state, and deployment criteria for slices in one of these shared networks. Here's another GSMA asset talking about network slicing. This is from another white paper called Network Slicing and Use Case Requirements, as shown at the bottom here. The reason I think this one is helpful and important is it really talks about something I mentioned a couple of times here so far already, and that is the notion of shared versus dedicated network resources. As I mentioned, in many cases, a 5G network is going to be shared in some fashion between services and use cases, unless it's an entirely private and dedicated network, as shown in the L0 case at the left-hand side of the picture here. But this is an important consideration. One thing I would point out is the set of standards and architectures around network slicing don't typically dictate to what level network functions are shared versus dedicated. That is a consideration of the operator implementing network slicing. In a way, that decision is made might be according to requirements, capacity, policy, regulatory considerations, and so forth. So an important concept here is that an approach to network slicing does need to anticipate this variability in terms of the operator preference and needs for what portions of the network are dedicated versus shared. A lot of discussion in the context of mobile has been around the idea of private networks extending 5G technology for special use cases that might not be part of the public network or might use specially assigned spectrum or those kind of things. So slicing obviously has a key role to play in that context. So I mentioned GSMA already. Today we're here talking with the Broadband Forum activities, but there is a vibrant ecosystem around network slicing. So many of the key actors are shown in this diagram. You know, again, it's from the same asset I just mentioned a few moments ago. But you see various industry groups, SDOs, participating here, and this is I think a good validation of the level of import and also consensus we have in the industry about the need for slicing. And a key concept that I'll reinforce now in the forthcoming comments is the degree to which slicing now extends in its relevance beyond simply the mobile network that was its original genesis. So I know Jan will be going deep on network slicing, so I won't do that. But key concept to bring up here is technology that has come about and is now in TR 370 issue 2 about fixed access network sharing. This is actually a perspective on how a concept like network slicing might be accomplished. Really, the purpose of FANS was to enable this notion of virtual network operators that share an infrastructure provider's network in some sort of wholesale arrangement, which is a common scenario in the operator community. But already you notice that there are some parallels to those cases that I described in the mobile network as well. And so, although FANS is really about how individual or different virtual network operators would coexist within an infrastructure provider's network, it is conceivable that this model that uses network orchestration, remember I mentioned that concept, also an SDN management and control layer could be brought together to interface to physical network elements, such as access nodes, aggregation nodes, and so forth, maybe with different domains for aggregation or transport as well as access, to create these different slices, if you will, or these different instances or contexts that could be used by multiple network operators. This same model, however, can be applied when those virtual network operators are in fact the same entity or the same company or the same operator, but having different requirements in terms of the user community, in terms of the configuration parameters, the SLA, and so forth. And likewise, the infrastructure provider network operators may be the same entity. So, this model is, I think anticipates a wholesale case, but is significantly is sufficiently generalized that it's an appropriate consideration for how we do slicing in the context of fixed network as well. Talking a little bit more about the activities of Broadband Forum, now TR 470, issue 1, issue 2 is in work now. The reason I highlight this is there's a good architectural picture, perhaps one of the best that I've seen, that really brings together that mobile network picture that I started in the discussion today and the fixed network. So if you look at the mobile part of this picture, these are the 3GPP defined elements shown in red. Here, there's some radio access network components, but we're also looking at the 5G core now. This diagram maybe goes in the opposite direction, but user equipment on the left and the core on the right. But as you can see, there is in this converged network a coexistence of the green elements. Those are the ones that would be specified by Broadband Forum, and coexisting with the red elements that are defined by 3GPP. As you can imagine, if this mobile network shown in red supports network slicing, and it is really, in essence, inseparable with or joined, converged with a wireline network, that slicing needs to be supported in both domains. So the activities of Broadband Forum do anticipate this, and you see mention of this in standards as well. I think there's ongoing work on this area about how to provide services for end stations and user equipment, and what does that mean from a standards perspective. But this concept that in Broadband Forum standards we call wireless wireline convergence is definitely a prevalent one for converged operators, especially, and is very relevant to the concept of network slicing. So given time here, I just wanted to end with a couple of reflections or considerations from my side. And the first is the reason to implement network slicing. It is fundamentally the purpose of optimizing the network for services, especially in the case of using shared infrastructure. One thing that we mentioned here also is that the standards and the technical approach around slicing don't necessarily dictate whether a shared or dedicated infrastructure should be used for each slice. And therefore, the optimal policy in doing so will be ultimately determined by the operator, and that freedom and flexibility is required. In order to realize slicing on an end-to-end basis, support for both physical and virtual infrastructure is compulsory, because a real network does entail both of these and will do so on an ongoing basis. And although slicing is and was a mobile originated technology, it also applies equally, if not more so, in the fixed domain, and most especially in the converged networks that we just talked about. There is a vibrant standards community and ecosystem around slicing, including here within the Broadband Forum, and any such successful approach to slicing needs to be open and aligned with industry standards. So within BBF, you've seen liaison with many of the other groups, contributions that you saw mentioned today. So last thing I'd say is this is an exciting area. We're seeing a lot of progress technically in realizing network slicing. And we're certainly taking action at DZS to help accomplish that. So with that, I'll thank you for joining us today. I think we have a quick break for questions before we hand it over from Jan from Nokia, who will double click on fans.
Yeah, thank you, Andrew, for that. We are running a little bit behind, but let's grab an opportunity to ask one of the questions for you, and all of the others that we will share with you post-event for you to respond to. So one question here, for a converged operator, today the mobile core is an overlay on the wireline network, and the 5GC retains an overlay philosophy. Is it necessary to start encapsulating all of fixed wireline traffic in order to do slicing? There could be a significant overhead from that.
Yeah, well, that's right. One of the philosophies of how converged networks, I think this question is from Jordan at TELUS, and it's a good one. One of the philosophies for how you would realize converged networks is, in essence, a mobile-centric one, which is where you make all of the traffic a payload on the within the mobile core. But that's not strictly necessary. There are other approaches, and in fact, for many networks that are not necessarily optimized for or primarily mobile networks, there is a need for a transition and or a migration or coexistence of networks that were designed to different standards. And for me, for us, there's this fundamental question as to whether the realization of approaches like network slicing should await the full realization of the go-forward standards. One of the things that we see in the practical world when we implement end-to-end service orchestration, which is a page that we're just starting here at DZS, is it's necessary to acknowledge the existing network, and really for large operators, the time that it takes to implement new technologies, and certainly the desire of operators across the board is to implement services uniformly, and there can be multiple strategies for doing so.
No, absolutely. Thank you, Andrew. Appreciate your time, and no doubt we'll hear from you very soon as well. So thank you very much, Andrew.